Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to be taking a look at sinusoidal functions and how to determine the amplitude. Let's go ahead and get started. So, the amplitude is simply this distance when you're looking at the distance above and below the x-axis, if you will. So if I had to give you like a little simple picture of it, you're trying to measure this distance here and this distance down here. Now, of course, this is a sine function right here. I'll tell you more about it in a second. It's sinusoidal function, in a second. But that's kind of what we're working with right here. And so the equation for this, let me draw the general equation first to just kind of get things started. So the general equation is going to be y equals a, we're focused on a today, that's the amplitude, times sine times the quantity of bx, bx minus c, and so b is how you determine what the period is going to be. And so we talked about the period last time. To figure out what the period is, you do 2 pi over b, the absolute value of b, and if that value, of course, is greater than 1, as we've already talked about it, if it's greater than 1, then the period is less than 2 pi, so it's compressed. If b is less than 1, it means that the period is greater than 2 pi, so it's going to be stretched out. We talked about that. Amplitude kind of follows the same idea. So when b is dealing with whether it's compressed or stretched. Well, a is dealing with the horizontal factor, whether it's stretched or compressed. And so with a, the rule is very, very simple. If the absolute value of a, and I'm going to show you the equation for this in a second, if it's greater than 1, then you're going to have something that's stretched. And of course, if it's less than 1, it's going to be compressed. Okay, and we're talking again about this vertical distance here, this vertical distance. So the general equation for dealing with this is as follows. Assuming that we're setting C, I forgot D. Plus D here. Sorry about that. So assuming that we set C and D to 0, we can calculate the amplitude as follows. Y equals amplitude sine. Amplitude is going to equal 1/2 times the absolute value of the maximum minus the minimum. And what we mean by maximum and minimum is the highest point on the function and the lowest point on the function. So in this example up here, like I've already showed you, I'm sure you guys remember this, I'll just draw it again. The maximum is 2. In other words, the highest distance that it goes on the y-axis is up to 2, and the lowest distance that it goes is down to -2. And so in this particular example, if I were to continue to work this out, I would say the following. I would say A equals 1/2 times the maximum is 2 minus -2, like that. Well, 2 minus -2 is going to be 4. So that means that now I have A equals 1/2 times the absolute value of 4, and that's going to give me an answer of 2. In other words, this distance here above the y-axis goes to the 2 and down to -2. And I mean, you can see that right here in the graph. It's very, very clear. Now, another thing we can do is that here, we know that going back to right here, we know that our A here is greater than 2, so that means it's stretched in comparison to the unit circle. So again, for the unit circle, the amplitude is going to be 1. In this example, the amplitude is 2 because that's greater than 1. All right, so you can kind of see this is not that difficult, but you just have to try to get your mind around how to do it and what's happening. So let's take a look at another one. So in this example right here, you can see, this might be a little hard to see, but I can tell you that it goes down to, looks like 0.5, so 1/2. So the distance here is 1/2, and the distance up here is 1/2. So if I wanted to calculate the amplitude, not using my eyes, but using the equation, I would do the following. So I would say that I would say that my amplitude will be calculated as follows. My amplitude will be calculated as follows. So as you know, it's going to be A, that's what we're working with, equals 1/2 times, so what's the maximum? Well, the maximum is 1/2 minus 1/2 like that, so that's going to be added together basically. And so now we have 1/2 minus 1/2, that's going to be the same as 1/2 plus 1/2 equals 1/2 times essentially 1, and then of course you know the final answer is going to be 1/2 again. So again, it's not that deep. It's just another tool for trying to describe the behavior of a sinusoidal function. That's what we're doing here. And so now, because our A is less than 1, because you can see 1/2 is less than 1, it's compressed. In other words, this is like, you can see that the distance is compressed. This area right here is smaller in comparison to the unit circle. That's when we talk about stretched and compressed, it must be compared to something. And in this particular context, we're comparing it to the unit circle, which is going to have an amplitude of 1. So this is smaller. This is compressed compared to the unit circle that has an amplitude of 1. So again, this video was not that deep in terms of just trying to figure out what amplitude is. So let me just kind of recap what's going on, and then we'll conclude the video. So in this video, we talked about how to calculate the amplitude of a sinusoidal function. So a sinusoidal function, it's kind of like a sine function, but not exactly. And it has some additional variables to it. You know, you have the C and a D and a B and an A. All these things are calculated to try to describe it in comparison to a sinusoidal function. Now, in previous videos, we talked about the period. That's where you use the B term here, the B variable. And I talked about how to deal with that. But in this video, we focus primarily on the A term, or the amplitude. And the amplitude is a measure of the distance, the height of the wave above or below the x-axis, if you will, or how high or how low it goes up and down, the top and the peak on the y-axis, if you will, however you want to think about it. And so this can be calculated by using this equation right here, this expression right here. So you do A equals 1/2 times the absolute value of the maximum subtracted from the minimum. And so when you do that, you're able to figure out what is the amplitude, or what is the distance, the height of the wave, the peak of the wave, how far is that, or how far is that going up or down. And so as we've already mentioned, if the amplitude is greater than 1, then things are stretched in comparison to the unit circle. So you can see here this is stretched. So the unit circle will stop here at 1, but here you can see it's stretched all the way up to 2. And then on the next example, you can see right here, when the absolute value of the amplitude is less than 1, it's compressed. So again, for the unit circle, it would be way up here, but you can see that there's quite a drop off. It's compressed compared to the unit circle. And so that's pretty much what we talked about in this video. So I hope that this made sense and you were able to comprehend and follow what we talked about today. My name is Derek Thomas. I am the Director of Educational Research Techniques. Take care.